Welcome to this explainer. Today, we are going to unpack an absolutely astonishing reality about a resource that we literally see everywhere, but are quietly and dangerously running out of. We're going to explore the true scale of shortages today, focusing closely on a material that sits at the very foundation of modern civilization.
So, think about this ultimate paradox for a second. We live on a planet covered in massive deserts and endless stretches of beaches. Sand seems like the absolute last thing humanity could ever possibly run out of, right? Well, a massive shortage of this seemingly ordinary material is actually threatening both our physical and our digital future. We are depleting construction-grade grain so rapidly that it's no longer just a minor supply chain hiccup. It's becoming a highly destabilizing force.
And it all comes down to a really bizarre geological paradox. You see, desert sand, even though it covers vast stretches of the globe, is completely useless for building. Millennia of wind erosion have worn those desert grains totally smooth and round, so if you try to use them, they just slide right past one another. Instead, we have to rely entirely on water-eroded sand from rivers, lakes, and coastlines. Those coarse, angular grains lock together perfectly, which is exactly what you need for concrete, glass, and industrial silicon.
Now, because we literally can only use that specific, angular, water-eroded sand, we are digging it up far faster than nature could ever replenish it. Global extraction is now running into the tens of billions of tons every single year. Let that sink in. That makes sand the most consumed natural resource on the planet, trailing only behind water.
To really wrap your head around the true scale of these shortages, just picture this. Imagine a massive, solid wall, dozens of meters high, wrapping all the way around the entire globe. The sheer volume of sand we pull from the Earth is enough to construct that wall from scratch every single year. It's almost unimaginable.
When you look at the raw numbers, it's wild. Sand and gravel are actually the most heavily extracted solid materials on Earth, totally outpacing even fossil fuels and biomass by volume. We always tend to think of oil or coal as our primary global extractions, but sand absolutely dwarfs them.
Section 1. The built world, concrete, and infrastructure.
Look, concrete is the literal foundation of modern infrastructure. It builds our housing, our hospitals, our highways, and remarkably, concrete is roughly 2/3 sand by volume. So as the global construction sector continues to boom over the next decade, the demand for this specific angular grade of sand is just skyrocketing right alongside it.
And you know the strain is getting incredibly visible. The sourcing for this grade of sand is so concentrated in just a few river systems and coastal zones that an entirely illegal, unregulated mining industry has just exploded. We're talking about actual sand mafias. In parts of South and Southeast Asia, this aggressive extraction has gotten so bad that courts are literally mandating live surveillance and GPS tracking on mining sites just to try and slow down the massive ecological destruction.
Moving on to Section 2, the hidden digital angle, covering silicon, chips, and screens.
This part of the story is truly fascinating. High-purity silica sand is the absolute essential starting point for silicon. And silicon, of course, is the substrate for essentially every semiconductor chip on Earth. You literally take raw quartz sand, refine it through this intensive purification chain until you get an ultra-pure silicon crystal, and then you slice it into the wafers that become the finished microchips, powering our phones, our electric cars, and massive data centers.
So, a tightening silica market creates a very real, incredibly dangerous point of fragility for us. We are dealing with a dual demand. The exact same constraint pool of high-purity sand needed to pour the concrete for your house is also needed for the microchips in your smartphone, for fiber optics, and for green energy solar panels. We are literally squeezing both our physical built environment and our sustainable digital future at the exact same time.
All of this creates a devastating ripple effect. On the environmental side, dredging riverbeds and seabeds destroys aquatic habitats, accelerates coastal erosion, and even undermines the foundations of bridges. On the economic side, this raw material fragility threatens the supply chains of next-generation chips and EV batteries, while causing global infrastructure costs to completely skyrocket. We're even seeing extraction being pushed further offshore into deeper waters, which threatens completely untouched seabed ecosystems.
Which brings us to Section 3, engineering our way out of the grain crisis.
So how do we fix this? First up is manufactured sand, or M-sand, and it is rapidly moving from a niche workaround to total mainstream adoption. Rather than relying on natural river erosion, which brings silt contamination and requires all that destructive dredging, we can now engineer our own sand. By crushing hard rock like granite or basalt, producers can perfectly control the gradation and the size of the angular particles entirely without destroying aquatic ecosystems. It's a game changer. And the adoption rate is frankly staggering. Over in China, which is the world's largest consumer of sand, M-sand now accounts for a massive 90% of their annual sand usage. Multiple studies have already confirmed that concrete made with manufactured sand can easily match or even exceed the strength of conventional river sand concrete.
We're also opening up a second front in this crisis response by turning everyday waste into raw material. Researchers have discovered that if you pull usable glass out of landfills, crush it into a fine powder, and substitute it for natural sand, it actually improves the compressive strength of the concrete. It is an amazing win-win scenario that diverts waste away from landfills while providing a vital second supply stream that didn't even meaningfully exist just a decade ago.
But listen, technology alone isn't going to save us here. Our policies absolutely must catch up to the engineering. If our economic incentives still favor cheap, illegal dredging, the scarcity will just outrun our technical fixes. We need to map and license rock quarries for trackable M-sand, actively enforce that GPS tracking we talked about, and fold sand right into our green building codes. And most importantly, governments need to start treating sand exactly like we treat oil reserves or rare earth metals, as a highly strategic resource that requires long-term planning and stockpiling.
When you step back and look at the true scale of shortages, it really boils down to this. Sand isn't just about beaches or brick walls anymore. It has quietly become the fundamental constraint on human progress, sitting right at the exact intersection of our physical world's concrete and our digital world's code. So I want to leave you with this final provocative thought to ponder as we wrap up today's explainer. The engineering to solve this is here, but the clock is ticking. Will our global policies and our circular economies catch up before the very foundation of our digital and physical future literally slips through our fingers? Thank you so much for joining me to explore this fascinating and fragile world beneath our feet and inside our screens. Keep learning, and I'll see you in the next one.